Okay. All right. So previously we looked at generics, and we pretty much just kind of immediately opened up a playground and messed around, kind of like we just did with protocols. Generics are, we're going to go over a little more of the kind of theory of them, and then some of the kind of weirder things you can do with them, including how generics work with protocols. We've only got about 20 minutes left, so we'll see how far we get. So first of all, what are generics? We talked about this last time, so this is a quick review. They are one or more placeholder types that you can use in any custom type that you define. And a placeholder type is a handy way of saying it, but it is technically called the type parameter. Okay? Generics allow you to minimize code for collections and things that wrap around other types that you're using. Things like dictionaries or arrays. The fact that they can work for any type that gets passed in is because of how generics work. And you can set limits on your type parameters using inheritance and where clauses. This is something that we didn't really get into last time, so that's kind of what we'll be covering. And we'll also be covering what generics look like in protocols, which are different. So here's a big, giant piece of code. Basically, generics work. Last time I showed you generics on types, but generics also work for functions. So you can have functions that have generics, and you can define a generic type. You can define a type parameter for functions, and it only applies to that function. It doesn't apply to the rest of the type. So here we have this extension array. We have this type alias key equals element thing. Don't worry too much about it. Just remember that array is a generic itself, and it has as its type parameter, it has one called element. Here I'm just renaming it to key. Okay, so within this extension, we can refer to the element type parameter as key. Okay, now within our function, we define a brand new type parameter called value, and you do it inside of the sideways carets, right? And that is just the name, and we're saying, hey, the zip function is going to have a type parameter. Inside of it, we will refer to it as value, but we don't know what it will be until the function gets called. Whoever is calling this function gets to decide what that type is, okay? It is an indeterminate type. So here we're going to call zip with values, and we pass in a collection of the value type, our placeholder type, our type parameter value. And then we also can return, we're going to return a dictionary, okay, where the type for the dictionary keys is key, which is another placeholder value, which is the element of the array, right? And then value, the parameter type that we defined for zip, okay? So it's doing a lot of stuff in here, okay? But basically what this is doing, if you kind of ignore like the code itself inside, on the outside you can kind of try and guess what this is doing, okay? So this is a function called zip that we are adding to every single array that exists in our code. Anytime we have an array, we will be able to call zip on it. Cool. Okay, so we want to be able to call .zip. Okay. So now we see this value, okay, and we're like, okay, that's nice, but we don't know what it's being used for yet, so we'll just keep it in mind, right? So then we see the argument label with, the parameter name values, and then an array of values, okay? And so we're like, oh, okay, got it. So the parameter being passed in is an array of indeterminate type. We don't know what the type of the array being passed in is, okay? And then our return, all right, is going to be a dictionary. That's weird. And it's a dictionary with, as its key, this kind of key parameter type, which is, we've just renamed it, it's element, right? So element is the parameter type for arrays. So if you do an array of ints, then element, or in this case key, is int. If you do an array of strings, then element or key is string, right? So our placeholder type here is, the element type of whatever array instance we are calling the zip function on. So we can see that happening down here. So if we say we have an array of strings here called keys, key 1, key 2, key 3, or key 1, key 1, key 3, right? And then what that means is this is an array of strings, okay? So element, which gets set to key, right? Change the name just for us because we're special, right? Key is the type, and the type in this case is string, okay? So if we call zip on the keys constant, then key is going to be string, okay? And then value, whatever that, type parameter is going to be, will be determined by whatever we pass in as a parameter, because Swift is very good at inferring generics, which we kind of talked about last time. So here we're going to pass in this values parameter. It's going to be an array of indeterminate type. Here we're passing it in. It's an array of ints. Okay, cool. So now we know that the return type in this specific case, just this time, just when we're calling keys in this way, or keys.zip in this way, is going to return a dictionary with string keys and int values. And when we print it out, we see that's exactly the case, right? And then it's doing a bunch of stuff in here where it's going through each array and then kind of combining them together into a dictionary, and it has some checks to make sure you never get an out of bounds exception, right? But yeah, so those are generic functions. Very, very similar to generic types, except it's scoped to just within the function, okay? Any questions about generic functions before I move on to the next one, which I think will be a review of generic types? It is. Cool. This is the stack. You might remember this. I made this last class. Stacks are easy. They're simple. It has an element parameter type, okay? And we create a stack that is an array of elements. We take in an element for push, and we pop an element as return. All the same as last time. Any questions about this before I blast right past it, because we already did it? Cool. So, inheritance constraints. Basically, whenever you create a function, generic function, or a generic type, whenever you define a generic parameter, or a parameter type, sorry, a generic type, parameter type, whatever, inside of your carets, you can provide a requirement, what's called a constraint. And you can say, okay, hey, listen, I am a function called getContent. Or sorry, not getContent. Let's say I'm a function called publish, because getContent's not doing this, but publish. I am a function called publish. I take in a type of indeterminate origin, but I want to guarantee that it is something that implements the content protocol. And so the way you do that is by saying t:content or t:protocol, okay? Yeah, so this is a constraint where you're basically saying, hey, you can call publish and you can pass any type to it if that type adopts and conforms to the content protocol, which we defined during the protocol section, okay? This also, you can apply it to, inheritance as well, right? If it's like, one of its super classes, like its great super class is, content, right? That also applies, okay? But basically, yeah, just that it conforms to this concept of content, whatever it is. Did I not go into the where keyword? Oh, maybe I do it later. Okay, so any question about inheritance constraints before we move forward? Cool. All right, next up is associated types. So basically, if you want to do generics with protocols, if you want to define a parameter, like a generic parameter type for your protocol, like let's say, for example, our content protocol. Previously, we were saying that our kind of underlying content data property, that we were requiring of our implementers was string, which is very limiting, right? How is a video stored as a string? How is a podcast stored as a string? Yeah, you could do the transcript, or maybe, try and, cast the bits and stuff into a string, but that's ridiculous, right? It should be stored as some sort of binary data, right? So when we look at that protocol content, we're like, man, it would be nice to be able to use generics here, right? And you can, but they're not called generics with protocols. They're called associated types because, again, Swift likes to be kind of weird. There's reasons for it, and I'm not going to get into those reasons right now because they are complicated and weird and not necessary. The thing to know is that if you ever see in a protocol, or if you ever define in a protocol the associated type keyword, and then you basically create a new, a new type after that, right? Just like you do for parameter types. Then moving forward in that protocol, you can refer to that associated type and know that implementers of anyone that adopts content, any type that adopts content, is going to have to define what content type means for them. They have to make a choice. They have to say, oh, okay, I'm a blog post, my content type is string. Oh, I'm a video, my content type is like MP3 file or whatever, right? Or I guess it wouldn't be MP4, right? Oh, I'm a podcast, mine is MP3, right? Etc. Okay? So that is what associated types are, and then you can see we use it again later on in the protocol, and that's just us saying, yeah, whatever type gets defined by our implementer as the content type, just use that there. And they have to conform to it and use that type there as well. Okay. So you also have this capital self. We've seen lowercase self before, and we have it right there as well. It's a way of referring to the current instance, okay? If you want to instead refer to the current type, because you might be a type of indeterminate origin, right, for whatever reason, you can use self, okay? So what does that mean? So if we have an array, okay, once again, we're doing an extension on array, we're adding a new function, and we're creating this alternate with array function, right? And basically we're saying, yeah, okay, so we want this function to take in an array of elements and return an array of elements. And we want it to be the same type as whatever we are, whatever the instance that's calling this function. So you have, say, an array of strings, and you call .alternate, then this function will expect to receive an array of strings, and it will give back an array of strings. Basically, it's just kind of a shortcut way of saying, for this type, instead of self, you could put an array of element, right? And it would know what it's talking about because element is the parameter type for arrays, okay? So it's basically kind of a little shortcut you can use for self. There's a few other places where you can use it, but yeah, cool. Okay, so the self type in generics, you can basically do this thing where you can kind of have types kind of refer to themselves. So let's assume that you are creating this kind of protocol called request, and you want to be able to wrap up requests. Anything that implements this protocol, you want them to be able to get wrapped up into a network request type, okay? So we have this network request down here, all right? And network request is going to have as its parameter type T that conforms to request. So basically anything that conforms to request can be used as the parameter type for network request. So you can wrap it around it, right? And then for our protocol request, we're going to have this function networked that returns a network request self. And what this is saying is basically, hey, this self, we're not gonna use it yet, okay? It's gonna be used by whoever implements us, right? Now, because we provide a default implementation using extension request, that means that implementers of request do not need to write this functionality themselves. And because we used self, the compiler is able to figure out, oh, okay, so by self, you meant the type of whatever this instance is, right? And so here, if we create this login request struct that implements the request protocol, okay? If we call .networked on an instance of login request, so we create an instance of login request here, you know, with the parentheses. And sorry, I haven't really used this syntax before, but you can just create an instance and then immediately call functions on it. You don't have to assign it to a variable first. So we create this login request instance and then we immediately call networked on it, okay? So when we do this, networked calls the default implementation on the request protocol, right? And so it's going to return a network request of self. And because login request is, you know, a struct that is called, it's called login request, right? Then self, the type self, is login request for this instance, which means that the request constant that we assign to its type is inferred to be network request wrapping a login request. Does that make sense? Any questions about that? Cool. That's that. I didn't talk about where clauses in here. I'm not sure where they went. I had slides on them, I thought, and they disappeared. I must have accidentally deleted them. Apologies. I will very quickly show you a where clause in action, and then we will be done with generics. So let's go over here. This is the playground. I create all the code that I use in the lecture slides. I'm sure it's in here somewhere. Here it is. It's wild that just disappeared. Okay. So you might recall and it's going to complain about a bunch of stuff because there's a bunch of further code that I need to implement, like up above, that I need to uncomment. So don't worry about it too much. But you might recognize, and I need to make this bigger again so that you can actually read it. You might recognize this from the slide about inheritance constraints, right? Remember, the publish function has a constraint on T where it must implement content. You can also do the same exact thing using the where clause. So with the where clause, you can say, after your function definition, after the return type and everything, at the very, very end, you can add this where keyword. And then after that, you can do this thing where you say, oh, okay, now I want to like say some stuff about the type, right? So this is a generic function if all of these things are true. And you can do a number of things here, right? So you can say where T implements content. And if content has like an associated value, like an array perhaps, right? Then you could say also, you know, comma, where content, you know, dot element implements something else, right? So we only want like this thing if it's content and if that content associated type is a string, right? And in that case, then publish as a function is valid, and that's something that you can pass, and otherwise you can't. So it's also kind of like a way of doing like protocol composition a little too sometimes, but it's basically a lot of different ways to do the same thing in Swift. Cool. So you can also apply where clauses to protocol definitions and conformance, and we will look at that more next class. Any questions before I let you all be free and enjoy the rest of your week and weekend? Cool. All right. I'm going to close this out and stop the recording.